All right, Josh, thanks so much for being here.
Yeah, thank you.
So I have a question for you. Do you consider yourself um, more of an entrepreneur or more of a scientist?
I would say more of a scientist. In fact, when I started building companies, I knew nothing about building companies, and I kind of didn't even like the persona of an entrepreneur. And so I think I'm a scientist that has fallen into, being an entrepreneur just because I want to solve problems that I think require that.
So are you still actively doing research and publishing?
So we are writing a paper right now, actually. And so it's not the research that I was historically doing, which was cell biology and a lot of, microscopy, but it's still research per se. And so we are publishing. It's different though, because we can kind of publish without pressure and, there's no timelines and kind of look at fun things. And so it's liberating in that sense, but we're working on a paper, right now and are getting close to submission.
Is it closer to the kind of meta science
So this
stuff
one
that you're
is
building?
Yeah, I mean, so I've always been interested in kind of how science has been done. So I've done my
Hmm.
work on the bench, but I've also looked at, how does peer review work? How do we fund
Hmm.
scientists? How does publishing work? And so I would publish kind of this meta science work, which led to the creation of some of the companies that we'll probably talk about. Um, and what we're working on now is describing one of the tools that we're building, Scite, so
Hmm.
that people can cite it. And I think we've already written a paper that uses some of the applications of Scite and some of the data, but we have never written kind of like how was Scite developed.
Hmm.
What is under the hood basically. And so we're at a point where we think it's kind of ready enough for that. And so
Hmm.
I don't know, it's come together quite nice, I think.
Oh, that's cool. So um, maybe zoom back a little bit. When did you when did you start this path towards being an entrepreneur? Was it with when you created the winnower?
Yeah. I mean, I think even before that, there's always kind of been some tendencies of me to second guess things or disagree with them. And I think if you have this kind of perspective on life, and I got this nickname in Little League is Bad Call Josh, because I would argue the calls and be like, this is what are you talking about? It's safe kind of thing. And I think if you have this kind of perspective, you're either going to be really kind of depressed and maybe negative, or you're going to be forced into like doing something about this. And so
Hmm.
that is how it was with scientific publishing. I felt like this is completely broken, and I was, bad calling it, if you will. I was writing papers like, here's why it's broken. Here's how I think it could be a solution to fix this. And then ultimately, I had some friends that had built a company, and I was like, well, I'm at least as smart as them, and their company was actually quite successful. It had nothing to do with science, and so I, naively and I would say idealistically and optimistically started a company, right? And I didn't know anything, right? I got $50,000, which at the time was tons of money to start a company, more than enough,
Hmm.
and jumped, into creating a better publishing platform at the Winnower. And obviously, it's much easier to say what you're going to do than to actually do it. And so a lot of learning, in starting that company and kind of where it went.
So I came across the winnower because I was doing some kind of reflecting on a type of science writing that I really enjoy, which I was calling a science preface.
Mm.
So it's almost like a kind of a preamble to a scientific paper that explains, why the researcher was interested in it or
Yeah.
what the kind of backstory was around that. And that's something that an interesting type of writing that you guys really highlighted there. Can you talk a little bit about that
Yeah.
genre of science prefaces?
Yeah, so I mean, I'm fascinated by that stuff as well, and I think the people behind the science and data are hugely fascinating. And I think this is actually how I got into science, was reading books by scientists.
Hmm.
And so the winnower, the idea behind the winnower is that peer review is valuable, but it's done behind closed doors. Even when it's kind of effective at finding major errors or rejecting bad studies, those studies still get out. It's
Hmm.
slow, and so why don't we publish things and then winnow the good from the bad via open post-publication peer review? That ultimately didn't really work because we couldn't convince scientists to submit their experiments and kind of their main research. However, we were having some success in getting kind of preface type studies, and it was
Hmm.
basically gossipy and a little bit more commentary on research. And in fact, that's how we seeded the site, like was saying, hey, you published this famous work. We'd love to know the backstory about it. Kind of like, was it hard to submit it? Was it hard to publish it? What
Mhm.
happened? And so we seeded the site with that. And basically I was honest enough with myself to say, okay, if I can't convince my own PI to publish our research here, but I can convince someone that's maybe going to win a Nobel Prize to publish their commentary, one thing's working, the other's not. So we doubled down and basically focused on, this term called gray literature, which is
Mhm.
pretty much everything that these big guys, the traditional publishers ignore.
Mhm.
And so we were, and I think this is why the winner had a little bit of success. We were kind of like a main venue for that, and we're also kind of a prestigious venue for that, which is silly, but it's more prestigious than a blog, or more prestigious than kind of not even publishing it.
Mhm.
And I think there's so many stories out there that are still not told, and I've kind of gone back and forth of like, well, maybe we could revive some of these things with like,
Mhm.
citation classics or supporting citation classics or altmetric scores, because some of those papers, there's one, I mean, that went viral because it's just so fascinating. And
I
it's
agree.
also, it's very personable too, because you'll be like, here's this paper that's, like really best journal kind of thing, like hugely
Mhm.
cited, like seminal paper. And
Mhm.
it was rejected like a bunch of times. The authors like felt, second guess themselves. And so it's really nice to kind of feel that, I think, because we all go through like, oh, that's a good scientist. I'm not a good scientist, but I think that's kind of a false assumption or feeling, really.
I'm with you. Every time I've come across writing like this, I just think, I love this. Why isn't there so much more of this? And I think it does, like you're saying, it just kind of fits with something that scientists are okay with. It's not where they're going to publish papers, and these are stories that people are usually excited to tell too. So I agree with you. Okay, well, we should keep scheming on that. So I want to, I've started companies, and when you start companies, you get going down a path, and then you have to put all of your kind of side projects on hold. You have all these adjacent ideas that you wish you could pursue, like we were just talking about, um, but you kind of put them on hold, and then all of a sudden you're in this position, a transition like I'm in right now, where you get to kind of dust off some of those old ideas. And so um, where did the idea for scite come along in this whole process?
Yeah, I mean, that's a really kind of good opening to kind of the foundation and kind of genesis story behind scite. And so scite was published on the Winnower as kind of like this side idea, and we
Hmm.
wrote this paper about 5 years ago in response to growing awareness around irreproducibility in cancer research, which is where my
Mhm.
research was. And so my co-founder and I wrote a paper and suggested a metric for reproducibility. And this was kind of a side idea. We named all these companies that should build it. Thomson Reuters, NCBI said, here's a solution to this. So you can identify which papers have been, we called it confirmed and refuted at that time, but we now call it supported and disputing, which ones have been, supported or disputed. And then you could build a metric off that, because we're treating citations the same, and they're not. And I think that's really the idea behind scite is, I knew this paper within my field was in Cell. It came from a researcher at MIT. It had been cited 300 times, but I knew it was wrong because I knew like 3 independent studies sprinkled amongst the 300 that that showed it to be wrong. But I wouldn't know that kind of if we left outside of the field. And so that was a paper for a long time, and I kind of it was gestating in my mind. We did a little bit of work manually where we would kind of talk with researchers and say, hey, do you have this list of studies that you know to be bad, because we want to like investigate the citations. And we did that, and I didn't even think we could ever like create this thing, right? And it's clear because we wrote, here's the groups that should create it. And then ultimately I was in this transition phase from the second company that I got involved with, Authoria, that was being acquired, and not acquired under kind of the best circumstances.
Mhm.
And clearly, if you have started a company, it can be hugely successful, but it can also be hugely difficult. And I think more people experience the hugely difficult part.
Mhm.
And so I was going through a pretty difficult transition and period, and clearly was a glut for more punishment, decided to say, hey,
Mhm.
well, here's this idea, here's this time now that I have to devote to it. I've kind of thought
Mhm.
about this for a long time. Why don't we try this? And that's
Mhm.
like kind of where scite came from, is is something that I've thought about for a long time on the side, did a little bit of work here or there, and then an opportunity where I could devote my full attention and time to it came about, and kind of jumped on it.
Hmm.
And I think looking back, there's always like kind of luck and timing things that makes so much sense. And I think timing
Hmm.
is a big one for why, Scite is working now. And that
Hmm.
is, the deep learning models that we're using were not so readily available 5 years ago, whereas they are
Hmm.
now. And so I think had we really tried to go full into like, creating Scite when we initially wrote the paper, it probably would have failed. And so it's
Hmm.
kind of fun to think about, this, fortuitous moment and kind of serendipitous moment, I guess, of
Yeah.
like creating the company.
Yeah, that's awesome. So, I do want to get to like a site kind of demo and walkthrough and kind of
Yeah.
and really dig into what it is and what it does. But before we do that, I'd love to hear in your own words the problems that we see with the current schema of citations.
Yeah, I mean, I think it's pretty simple. Is that we call citations at Cite Smart Citations, and I think that is because the other ones are kind of dumb, right? We're treating them all the same, despite the fact that they're very different in many cases, right? So you can cite a paper because you're using it in the methods, or you can cite a paper because you agree with it, because you disagree with it, and to get that contextual information and to understand why a paper is being cited is hugely valuable, but it's not readily available. And so I think we want to, go from, how many times has a paper been cited to how has a paper been cited. And that's really kind of the aim of Scite, is to unlock all this information that's contained within this number and to make it digestible so that it can, you can better inform yourself. What does the literature say about these things? And so not just a number, high is good, low is bad, which is, I think, really kind of where we are. And I think, some of the interesting things that I've learned since then is that, citations don't just exist in science. They've existed in law for quite a long time. And law has different ways of assessing, is this good law or bad law? Because there's different types of citations and things like this. And so the approach that we're building in science has existed in law for over 100 years, called shepherdizing. And we're
Mm-hmm.
effectively kind of bringing that strategy, something that we thought we had invented,
Mm-hmm.
to science.
That's interesting because my girlfriend's dad is a lawyer, and I was talking to him about some of these problems, and he said, we already have software that does this, and so I had that kind of that same kind of epiphany. This kind of speaks to something I've been wondering, and I'd like to get your opinion on it. This kind of digital revolution has happened, right? In music, in movies, in law, and it's happening in medicine and manufacturing. And science is one of these last holdouts where it should be something that makes the process go so much smoother.
Mm-hmm.
But for some reason, the kind of the bulk of scientists and the kind of center of gravity of the whole thing hasn't made the transition. Even the discussions around open science, to me, like they started down this path, but now we're just talking about like arguing over preprints,
Mm-hmm.
and it feels like it's stuck. Um, would you agree with that? And why? What is your thinking and on why that is?
Yeah, so I mean, I would agree with it, and I think, oftentimes I think, okay, this vertical, this space that I'm trying to build a company in is not easy, right? You're selling to some of the kind of the most opinionated, critical people, whereas you could kind of go sell to people that don't, react that way or think that way. And so I think science is, is kind of an institution, an enterprise, is very tradition bound, right? And it takes value in that. And so there's some things that are hard to lodge, and there's like clearly things that are technologically better that just, if they don't fit or like fit within kind of this social narrative, they won't get any traction, kind of. And so I think, like, kind of the way I think about it is, there's groups and verticals and companies and people that care about like money, and there's nothing wrong with that. I think it simplifies a lot of things. It's like, okay,
Mm-hmm.
here's something that I can make you more money, or here's something I can do to make you more money. I think science kind of lacks some of that. you can position like, publications or citations as a type of currency for scientists, but scientists, like most of them, don't get into it to make money. And so I think like they get into it, a lot of it is to make discoveries, but it becomes tied into ego, and you become part of the process that is trying to improve itself. And so I think this is like a very kind of meandering response, and I think maybe that's a reflection on the fact that it's highly complex, right? It's
Mm-hmm.
just like such a complex field, and I think it's challenging to build because things in there, because you need money, you need outside money, and oftentimes the people that will give you money want more money in return,
Mm-hmm.
and
Mm-hmm.
so they're like, well, why am I going to give you this money to go invest in a space that is really hard to do anything in? But I think that,
It's
yeah.
no, keep going.
I mean, I was going to say, I think kind of the rewarding thing about this though is that like, and this is, I've heard from like investors that have like passed on us, is like, well, we don't think you're going to make tons of money. We think you're going to make a huge impact. And I think there's like this trade-off, right? And not necessarily trade-off. Like for me, it's like finding this kind of alignment where it's not, you're just making a ton of money and you're doing something you hate and like, there's no kind of positive impact on the world. And I think like, Cite is not making billions or even millions of dollars per year, but it's making a large impact already, I think. And so I think as those things become married together, that is something that is extremely rewarding. And you can see kind of like a lot of founders that have started like ad tech companies going into more meaningful type ventures later on because they kind of want something more meaningful.
Mm-hmm.
But yeah, science and scientists is tough because a lot of people have never left academia. And so, there's really different types of incentives and things like that.
I'll tell you what, that's my favorite reason for kind of hanging around this. I guess it's kind of like a science entrepreneurial scene, right? Like, like we're both in this jelly Slack and it's
Mhm.
full of folks like that. I think this is such a great group of people because I don't think everyone is motivated by money. I think
Yeah.
everyone's motivated by this, having this bigger impact, and the opportunity to have that big impact is very real.
Yeah.
So I think it's a great time to be hanging out with that crowd. So,
Yeah.
um, okay, well, I'd love to kind of share your screen and see how you use Cite and kind of really dig into some of the details and kind of have you explain smart citations in your own words.
Cool. Yeah. So, and feel free to kind of interrupt or ask any questions as I go through this. So
Cool.
the way that I, like to show Cite is to show the world as it exists without Cite, and then to show it through the lens of Cite. So this is my PhD work, which was looking at chromosome segregation defects in human cells, cancer cells specifically. We published our work in eLife. I did my PhD at Virginia Tech. We collaborated with the hospital in Portugal as well as the lab at the NIH. My work has been cited 46 times, according to them, and then viewed almost 8,000 times. And so this is what we all kind of look at when we first see a publication. Where was it published? Who are their authors? What are their affiliations? And then some metrics, so views, downloads, and citations. And so in today's world, I would say most people are not clicking this number 46 to see what are 46 papers seen about this article that I'm interested in. If you do that, you will come to a citation index like Scopus or Web of Science. You'll see a list of papers that refer to this. If you have access to that, you may click a few of them and go see what it's saying about this article that you're interested in. But I don't think people are doing this systematically. And I think that is a huge, kind of missed opportunity, because within these 46 papers is, millions of dollars of work, years of work directly related to what you're interested in, and you're not getting anything except for this superficial number. And so wouldn't it be great if you could digest this information and understand, how has the literature received this article that I'm reading? Has it been supported? Has it been disputed? Have others done similar things in different fields? And so we built this browser extension for Chrome or Firefox and even Microsoft Edge recently. And basically what it does is give you, kind of the lens of Cite anywhere you're reading a scientific article online. And we're currently investing and focusing a lot more on that to bring that power kind of into other products and services. And so if you click this, it brings you over to Cite. And what you can see is, we have basically the same thing up top as the article. So the title, the authors, the abstract, and a link to back to the version of record. And then what we do differently from other citation indices is that we show the context. So what is this paper saying about my work? And you can see, they say Nicholson and colleagues found that the overexpression of one gene, SPAG20, expressed in cluster 13q 13.3 promotes cytokinesis failure in DLD1 plus 13 cells. And so they're describing my results. They're not indicating that these are like the best results or that they're the worst results or that they found something different. And so we classify this as just mentioning. We have deep learning classifications that have broken down these citation statements into, do they indicate there's supporting evidence or disputing evidence? And so if you select for that, you can see a difference. And so this one says in agreement with previous work. And then there's the citation to my work. The trisomal clone showed similar aberrations, albeit to a lesser extent, supplemental figure S2B. And so this paper, 3 years later after mine came out, found a similar finding, which is if you put an extra chromosome into cells, they have more mistakes. And you can see, where did this snippet or this excerpt come from? It came from the results section of this paper, which was published in MBOC. You can further, search these citations snippets if you wanted to find anything that related to yeast. You can click on related citations, which I think can help find related papers that you may not be aware of. And more generally, you can just kind of go through the context and say, what are all these different articles saying about this? Say you're looking at methods and you wanted to see how 10 different papers or a couple different papers did the same method section. You could look at the method sections and see if there's any, differences between that. We offer a visualization of these, which really kind of shows a conversation amongst papers, I think. And so here's my paper, and here's how I am citing Zhu et al. 2012 is over here. If you start to look at this paper, here is Vigano, the one that I showed earlier, saying in agreement with previous work, etc. And so this is a way to really kind of see, how does this fit within the literature? You can expand beyond supporting and disputing sites to mentioning sites. And you can even expand beyond those, adding multiple papers in there. And so really starting to kind of take this corpus of knowledge and the scientific network and trying to help you understand it better, beyond just like, here's how they link, or here's a link between papers. It's more, here's how they link, so you can get through these things. And I think, one thing that we are addressing, and we didn't kind of focus on this initially, is this information overload. And I think the world especially feels that right now with COVID-19 and this massive amount of information that comes out from preprints. How do we know what is reliable? How do we know what is not? How do we even keep up with that? And I think Scite can start to help with a lot of that. And so
does it work with preprints too?
Yeah, it does. And so if you go to medRxiv, you can see, and I think the interesting thing about preprints, so here's one which has not even been published yet, and we already have this amount of citation statements. The interesting thing about this is that preprints have changed kind of the lag. So citations are a lagging indicator, right? A paper comes out, oftentimes it's months or years or even decades before citations start to accumulate. Whereas in preprints, we have started to see, and I found one example, within 5 days, a citation appearing. And so I think that is really interesting to me. And I would say, out of these 81 citation statements, most of them are coming from preprints. And so we're rapidly processing preprints. And I think that can be useful to better read preprints. Maybe it can be useful for editors to say, oh, here's a preprint that I should be interested in. We would like to invite them for review. Or maybe they can even use some of these as reviews in themselves. So going back to Scite, so how do we do this? I think is kind of the next type of question that we get, is like, okay, this looks nice. So in order to build what we've built, we need access to full text publications. Getting access to full text publications is not easy because most content is not open access, while a lot of it is. And so we've signed indexing agreements with a lot of major publishers, and we're signing more to gain access to their content so that we can process them. Once we have that content, it comes in kind of really two formats. One is structured text, XML, and that's easier to parse, but most of it's still in PDF, which is not designed for machines to digest and analyze. And so we work with this open source tool called Grobit, and the founder of that, Patrice, who's really, I think kind of one of a kind. And this is Jelly, I think, is using Grobit as well in some form.
Mm-hmm.
What Grobit does is basically take a lot of machine learning and identify in-text citations like this, matches it to the reference, and then matches that information against Crossref. And so we are basically kind of taking a bunch of software and machine learning and digesting these papers to get out these citation statements. Once we have those citation statements, we have one deep learning model that has been trained on roughly 40,000 citation statements to classify it as supporting, disputing, or mentioning. And the way that we've done that, it was basically as humans to read citation statements and build training data and say, here is a supporting citation statement, here's a disputing one, and that's the 40,000 citation statements.
Wow.
And so we've done a lot. We've analyzed, over 23 million full text articles, which is 792 million citation statements. But we still have a lot more to go. And there's still some large publishers where we don't have access to their content. And so this number is, jumping up a couple million per day, sometimes more, sometimes less. And I think, the billion kind of mark is where I think we'll really be excited, which is also challenging, right? Because it's not cheap or easy to process this amount of content. And, not a lot of startups have to kind of deal with this so very early on. So
that's awesome. That's really cool. So, one of the kind of the with preprints and especially with COVID and how that's accelerated so much stuff. How do you see this tool being used to help with that acceleration in terms of, like if anything gets retracted or anything like that?
So I think we have built something that is pretty unique. And we think it can apply to a lot of different, workflows and data. And so our strategy is to kind of go where researchers are so that we can help them better, cite something, better evaluate things. And so a few things that we're doing to that is again, expanding kind of the browser extension so they can take our information into other products or other websites. Another thing that we've introduced is the reference check. And so, sorry, I got to move you around. The reference check basically takes what we've done on the back end or what we do on the back end for millions of articles and applies it to an individual PDF that you have on your laptop or that's been published. And so basically we will, take our ingestion apparatus and ingest one article. So automatically detect the references, match that against our citations, and then flag if anything has an editorial concern, so a retraction, a withdrawal, a correction, etc.
Wow.
So this allows authors to upload their manuscripts before they submit or while they're writing to check and make sure that their references are reliable. And so in this case, this is actually a published document that is referencing something after it's been retracted without acknowledging that it's been retracted. And that is a problem that, is happening daily, is this citations to retracted content with the authors not being aware of that. In fact, we've even built this fun Twitter bot, which is called Scite Ref Check. And this tweets out a tweet every time a new article cites a retracted article. And so you can see it here, and you can see this one, from BMC Pregnancy and Childbirth was published in 2020. It's citing something that was retracted in 2018. And so the idea is to kind of highlight this problem, help authors solve this problem, and then also help journals. And so we've tied in this reference check into submission systems, which is where I think the real traction will be, because that's where, that's the pipeline of papers. Millions of papers go through these submission systems. And if it's one button and you get to know that you're referencing something retracted or highly disputed, it's much easier to correct. And so that's just happened. We're in one now, and then we'll be in two very large ones early next year. And I think that is to help stop the spread of kind of like citations to retracted articles, but also to help authors make sure they're citing things that are not so strongly disputed that they don't want to be citing it, or maybe will help them write better and different like that. A bit related to that, we've also developed this plugin.
I follow that Twitter bot, and it's real shame. It feels like a real shame, public shaming.
It's a stick. I mean, it is a little bit of
Yeah,
a stick on publishers because publishers don't want to, show this. And if you go to a
right.
lot of these retractions on the publisher sites, they're uninformative, they're hidden,
Mm-hmm.
because it's something that they, feel that they made a mistake. Although I don't think it's like, fair to blame a publisher that something got retracted necessarily, because
Mm-hmm.
peer review is not kind of designed to detect a lot of that. And so it is a little bit of a stick and like highlighting, hey, here's a problem and we're going to like show this problem unless you start to fix it, which obviously ties back into something that we're trying to sell to publishers.
Mm-hmm.
And so,
So,
related. Yeah, go ahead.
well, I was going to say, so, this isn't, you guys have built an amazing tool. Um, it's really impressive. I think, who do you view your main kind of user and customer? Is it the researchers? Is it the publishers? Is it the funders? How do you
Yeah.
think about that?
So I think it can be all of them, but I think we have to choose like who are the ones that we kind of focus on first, and kind of how do
Mm-hmm.
we go to that first. And so we have spent most of our time talking with academic publishers. And the reason for that is that, A, they speak the language of citations. They understand this fully. This is how they judge themselves, how they judge papers, all these things. And this is a very novel, way of looking at citations. B, they're very strategically valuable to us, right? So without
Mm-hmm.
access to full text, we can only rely upon open content, and that can only get you so far of the way. And so
Mm-hmm.
we need to work with publishers. There's just really no way around that, because, this publisher holds this publication. There's no different publication that is the same as that. So there's only, unique types of publication. And so we need to work with them to gain access to that. And I think, we've kind of evolved our thinking of like, what do we charge them? Should we be charging them, or like what makes sense? And ultimately, we don't charge for indexing. We also don't pay for indexing, which I think is important, because they charge, lots of money in many cases to countries and universities to gain access to this content.
Mm-hmm.
Um, we have a badge, which looks, like, what is a good example? They actually just changed the one that I always show, so I don't want to show that. We have a badge that looks, actually, why don't I show here? That publishers can embed on their articles, that will
Mm-hmm.
show this article has been supported or disputed. Initially, we were trying to charge for that, but I think we're not enough of a standard or enough clear kind of value that they had to pay for that, right? Like maybe some of them wanted to pay for it, but a lot of others are like, it's too much. I don't know how it's going to help, my journal, kind of things like this.
Mm-hmm.
Um, and so I think we have done a good job kind of working with publishers, getting access to content and providing them value, both in terms of metrics and also something that can help, their submission systems. It's something that they, really care about, helping their peer reviewers and things like this. And we've started to shift a little bit, after, the better part of last year, focused on infrastructure, data, freshness, getting the data accuracy, all these things, to where we've now built a lot more researcher facing things. And the researcher and like facing things are almost easier to build, or they are easier to build. It's just without that data, they're less useful. And so some of these things are this reference check, building integrations into reference manager like Zotero,
Mm-hmm.
and so that we can help the workflow of individual researchers or administrators, which may be like bibliometricians, utilize our information in a better way. And I think there's still a lot to do, and there's so much to do that it's hard to kind of stay focused. And I think that's why like our focus is, let's really focus on citation contexts, and classifying citations, and then we can add that and partner with different groups that provide value in different way to co-sell or kind of co-market, if you will.
I
And so
love
that's
that.
kind of our thinking.
I love that. That's really cool. You said you're kind of working on a paper now, and doing research now. I'm wondering, if you're open to it, and if you're not, that's fine too. But um, just showing how you actually are using this tool, and how kind of, or how you're putting together that research outside of it,
Yeah.
or
So,
or yeah, or some, like some, like, that what I'm trying to get at is like, um, I can imagine how people are using this. I would just like to see how you do do it. But if, anyways, go ahead.
So I think it's interesting because I think I don't use it like a typical user. And like today I
Mm-hmm.
actually did for a little bit, right? Like, kind of eating your own dog food, like where I'm just searching for the pleasure of things, like looking up chromosome segregation defects, or even like, I was looking up citations and Eugene Garfield and like stuff related to the work that I'm working on now. I don't
Mm-hmm.
typically do that because I'm so focused on like, does this make sense for like a new person coming to this product thing, giving demos, sales, and I would say like my time is more focused on like looking at Scite as a product and less as like
Mm-hmm.
a user.
Mm.
Um, and I think, it's good to have both approaches, obviously, because I think if we can build something that is useful for us, it'll, as researchers, it'll
Mm-hmm.
propagate out.
Cool.
And so I think that the value that I get, if I'm being like super honest, from Scite is the extension, right? The extension allows me to read, you know, basically to get our information on any type of scientific article. And I get, so many questions from family and friends about all kinds of things because I have a PhD. They think I'm an expert in everything. And they'll say, what about this? What about this? What about this? And I say, I don't know, but let me go see what like the literature says. And this just helps you get through the literature, a lot better, especially in new fields that you don't know, kind of all that inside information and gossip.
Mm-hmm.
And so I think that it's just made me a better, reader, because I can look at things and say, oh, I trust this because look at, there's 4 other groups have said they've found similar findings. And I could do that very easily without having to consult experts or to do like a systematic review. In terms of like how I kind of write papers, I think it's less interesting because I don't like, historically I was using Microsoft Word and EndNote, and these are things that I was just trained by, the
Mm-hmm.
professors I worked with. But now I don't want to pay for Microsoft Word. I also don't want to pay for EndNote. And so I use basically Google Docs because we do a lot of collaborative writing. And then Zotero because it's free for my use. And
Mm-hmm.
so I think it's my use in writing have shifted, which is more of a reflection, not on Scite, but on what can I use for free now, no longer that I'm associated with a university that's paying for it for me.
Mm-hmm.
Um, and I think it's hard to kind of like separate or like to put myself in the shoes of like the researchers. And so oftentimes what we do is it's kind of like this, sit down with researchers and ask them, say, hey,
Mm-hmm.
what is your workflow like, right? How can we
Yeah.
help that? What can we can fit on that? Because we have this, kind of, we know what Scite does and we know what it can do, but it's like until you see a researcher what they're doing, you're like, oh my God, you're going to Google Scholar no matter what. Maybe we should somehow integrate with Google Scholar better,
Mm-hmm.
or PubMed or things like this,
Yeah.
or Zotero. And obviously, we don't want to reinvent everything.
Mm-hmm.
And so I think learning where we can kind of integrate and how we can help certain processes that people are already doing is the best way for us to kind of get integrated into those streams. And I think we've started to do that very recently, and I'm very excited for like some of these things are really easy to do, like extending the browser extension so it like works in
Mm-hmm.
PubMed much better. It's easy. We just haven't done it, and so we're
Mm-hmm.
going to do it like really kind of like today in this week type thing. And it's
Cool.
tell you the people that love PubMed that are like have been using it forever and are not moving no matter what.
Mm-hmm.
This is like a good way for them to feel the power of kind of what we've built.
Wow. One of the things that I do on this kind of this, I don't even know if it's a show, it's more like just a project, but uh, um, is ask people how they do their research and like where they, how they read papers and kind of go through it. It's interesting for you. You've taken that question so seriously that you've
Yeah.
actually gone and built this tool that it's a, it's like a, it's, it's an additional lens, right? Like it's like a compass that helps you navigate this morass much, with added skill, which is really cool. So congrats. I think it's awesome.
Thanks.
Um, do you have anything else you want to show me on this?
Yeah, I mean,
Or
I think there's a few more things that are really interesting. So,
okay.
generally when researchers first find out about Scite, they search themselves, and they're either going to
Mm,
love us because we say, "Hey, look, you've found supported work," and oftentimes, like, they don't know that they've been supported, me included, right? I stopped following the literature so closely after I, left my PhD. And as I was building this, I did what everyone did. I searched myself and I found a supporting citation, and there's a tweet when I found it because I'm like, oh my God, this is so cool. And it's so funny because I'm like, a driving force behind creating this tool and I didn't even know, right? And so
mm,
that's like an aha moment that we really try to optimize for, is like helping researchers show that they've actually been supported. And I think that is something that would be very powerful for like tenure and promotion, is not just, I've been so highly cited at all costs, but look at, I may have only have 40 citations, but I have 2 groups saying they found something similar. And that is very powerful. And so I think, this ego, people searching for themselves, is kind of one thing that we try to like recognize and say, okay, people care about their research or their field. How can we, again, and I really like that used lens, how can we give this lens to them so they can see through scite? And so one thing that we've done is to create the ability to create dashboards, and so you can import your entire Zotero library or your Mendeley library, or just drag and drop 1,000 article DOIs into there to see how are these things cited, which one is the most supported, which one's the most disputed, and then to receive alerts when those things change. And this is something that pharma companies are actively paying for. They care about publications that relate to drug X, drug Y, drug Z. They can create a custom dashboard on all those and receive alerts when things change. But so can a researcher that cares about these. They can create a custom dashboard based on cytokinesis, and one on chromosome segregation and things like this. And I think that has been really cool. Naturally, citations apply not just to articles, but they also apply to journals. And so we have created these journal dashboards which show our information at the journal level. And so if you click this journal, which is a math journal, you can see that there's about 12,000 total publications. Here's the citation breakdown of them. We're even now showing editorial notices, so how many corrections, errata, or retractions have appeared in this journal. How does this look over time? And then again, you can start to see which is the most supported or most disputed article in here. And one thing that we've introduced, which is a bit contentious by some, but to me is kind of just a simple ratio, is this cite index. So does this journal receive more or less supporting cites, basically? And how does that look over time? How does that look within different time periods? And one thing that's kind of cool about this is math. If you look in math, they receive, some of the most supporting citations, which I think, is somewhat of a validation and kind of makes sense, because, the nature of math is that it is proven, right? And so there's only going to be so much kind of debate. And so if you take this cite index, and so each of these dots is a journal, you can compare it to the impact factor. And so the impact factor is how you measure a journal, right? High impact factor is good, low impact factor is not good. What we've done is to take that and look against the impact factor, and we didn't see any relation. And this is, candidly, this data is old, and so it needs to be redone. We also then broke it down by different fields. And so you can see math. So here's all the journals. Here's math. They're up at the top, right? There's a lot of supporting citations. And then if you go down to physical, chemical, and neurosciences, also a lot of supporting citations. To where you get down into clinical, and I don't know if it's good or bad, there's a lot more debate, if you will. And I think this reflects, realities behind the different disciplines, also probably partly how scientists write, I think takes into account. And it's an empirical question that we can answer if we had, more time, which is, which really matters. But I think, these are some of the things that kind of cite opens the door to. You can bring this kind of lens, not just to journals, but also to funding institutions. So which, company, say you wanted to look at Roche, what are these different companies funding in terms of their research, which is the most supported, which is the most disputed? Ideally, we'd bring this to universities, and there is some overlap here. It's just right now, a lot of this data is not openly available, and it takes time to process that. And again, we don't want to try to bite off too much that we can't choose. This could also apply to people. And so I think, bringing, and that's why we focus on citation. They're so central to all these things. And so if we can improve them, we can improve a lot of different things that are core to kind of scholarly communications, which is core to I think science itself.
Wow, that's so cool. Well, this is a great tour. That adds so much. I mean, I think, what I'm, as kind of a newcomer to it, what I see is, first and foremost, this is, like I said, like a lens, like a helpful compass in navigating research. I think that's really interesting. But you guys have been kind of peeling this onion. It's like, what happens when you have that kind of tool? and it really does allow you to look at journals and funders and metrics with a whole new light. So that's really cool. I'm excited to see um, how people are using it, but also how people um, can continue to peel back that onion and figure out other ways to use the tool. That's really interesting.
Yeah, I mean, I think, this is why it's fun to build this. It's fun to see how people
Mm-hmm.
use this in different ways. And then it's,
Mm-hmm.
I tweeted out something which I think you saw this morning. It's really rewarding to see some of these people that are so hard to convince to do anything different, take
Mm-hmm.
this and say, oh, wow, this is, helped me uncover this or change like my behavior. And I think that is, personally rewarding and makes like building the company, which can be sometimes isolating or difficult, very worthwhile and kind
Mm-hmm.
of also easy to turn down, like offers from groups that just, want to buy you and kind of change things or like close up shop. And so yeah, it's exciting to see where we go. And I think, the corpus of scientific publication is just it's untapped in some sense, right? It's used for reading, it's used to sell subscriptions, but the machines, which we now all have kind of access to, can look at it in so many different ways. And I think the onion is a good way. I always say like kind of lemons, like there's so many different
Mm-hmm.
ways you can squeeze this lemon and get interesting information out of, and
Mm-hmm.
scite is one example. But you could clearly process other parts, images, tables, affiliations, and things like this. And I think, us showing that it can kind of be done and it can be done at scale, I think will open the doors for others to kind of look at this and take really kind of novel approaches as well. And there are other companies already, starting to look at images and things like that.
Wonderful. Cool. Well, you can stop sharing if you want. I just have one more question for you, which is the question I kind of ask everyone at the end. Is what are your ideas to make science better? I know there are lots of them, and clearly you've been building a tool solving one of those problems. Do you have anything else you would add to that list?
Yeah, I mean, I think they are ultimately like embodied in what I'm building, right?
Mm-hmm.
Obviously, but I do think there are a lot more. Um, I think, peer review, which is not just used to kind of determine if a paper will be published or not, but determines where money will go, is something that could use a lot more experimentation on. And I did some like kind of earlier look at the, work at this, and it's just, funding is tight. There's more and more PhDs, and funding hasn't dramatically risen, and so it's extremely competitive. And between like a grant that gets funded and an amazing grant that doesn't get funded, right, there's really no kind of difference. And so I think it would be very interesting to kind of explore different types of funding models to fund work that is maybe out of fashion but could have big consequences and things like this. And it's really hard to kind of run those experiments because only groups that can do that are the ones that control like the purse strings, right? The government, which
Mm-hmm.
is probably not going to do so many different types of experiments. Foundations, I think, could do a lot of interesting things. CZI, which has tons of money and wants to
Mm-hmm.
cure or eliminate diseases, I think they should be trying things that are much more kind of out there in terms of funding. Not
Mm-hmm.
here's a call for application, send us a grant, just like the NIH. I think it should
Mm-hmm.
be let's really swing the bat, like almost like venture capital in some senses, which does fund science. I think that would go towards helping a lot of different things. But yeah, I think there's a lot that is amazing with science. It gives us all these powerful things. It informs basically every aspect of our life. But there's a lot that could be improved upon. And I think turning the lens on yourself and kind of this meta science is really fascinating. And I'm that's why I like like you like these personal stories and people building tools to kind of like help scientists do better work, because that is kind of the output of that. And so that's it's no like kind of easy answer, I guess, is funders should try kind of more things to experiment with, because
I like it.
if there's no money, you're probably not doing it. And then that's just it doesn't matter about publishing, you just didn't have the resources to try these things.
Mm-hmm.
um, and that is one more thing just before I go there. I think like if I had this, I used to had lunch with this old professor one time. He said, what would you do if you had like all this money? And I mean, I think I said something like, I would fund your research or something very like kind of sycophantic. But I think what I would do is like, I would do something really kind of crazy out there that I don't think any like funding would like come from. And I think that kind of stuff is what interests me, is like the stuff that is probably going to fail and probably not going to work, but it's like super interesting and maybe could work, and you discover things. And I think
Mhm.
there's no real good funding mechanism for that. Even venture is like hard to kind of get there.
Mhm.
But yeah.
Well, one of the things that's interesting, like I've been thinking a lot about funding, is you're with companies, you have the entrepreneurs and the businesses and the customers, but you also have this layer of um, group called investors, right? And that's their job, to allocate capital and to think about it. Venture investors or public markets, whatever. In science, what you have is just scientists and the peer review process making the decision. It's almost like if we allocated capital through our economy just through the Fortune 500 companies, like they were the only ones who could figure out where to spend money. And so I think we're kind of missing a person in science. Like program officers are kind of it. And I think DARPA has shown that you can have kind of ambitious and um, independent program officers, but
Mm-hmm.
I think we need to do a better job measuring them. First of all, identifying them and giving them credit for the risks that they take and do that. But anyways, I think that's a missing piece. And that's my own kind of hunch there. I don't
Yeah,
mean to add on.
and I
I
agree,
liked
and
your,
yeah, no, I think it makes a lot of sense, and I think it's funny to bring that in investor kind of analogy, because the way peer review works is, you are a leader in this field, and
Mhm,
someone is coming to you basically with a submission. If you try to challenge that person's idea, right, which maybe you should, you are
mhm,
not, going to likely get funding, right? If you told me chromosome segregation, this is nonsense, and et cetera, I'd be like, well, I disagree with you. I'm not giving you money. And so
mhm,
this is, where I think this kind of saying like science advances one funeral at a time is because like, a lot of the people that control the purse strings are directly tied into like defending that through their
mhm,
ego and money, right? And so it would be like going to an investor that's made an investment into a competing company and saying, hey, well, we have a company that says your company's bad, give us money. They're probably not going to do that, right? They've already kind of bet their horse. And I think that is, I used to have kind of some proposals of like, maybe we should bring people not experts within this field, but can understand it, so they could kind of fund some things really out there or differently.
mhm,
But I think ultimately what needs to happen in publishing and all these different things is experiments. And this is like every time we have a debate on Slack, and this came from actually the lab, is we have this saying, which is probably not appropriate for your show, which is DTFE, which is do the effing experiment. Because it's like,
mhm,
it doesn't matter what you or I think, right? Go out and test it and see if it works. And I think
mhm,
that's what I wish would happen in all these different cases. Like, experiment, try it, right? And maybe it won't work. Maybe it'll make things worse, but at least you'll then have the data and you can improve upon that thing. And I think one thing that was really interesting that led to kind of the winnower was this guy, Richard Smith, who was his editor-in-chief of BMJ. He did do that. He did all these experiments. They would put in artificial errors into peer review, into papers, send them out to peer reviewers, and they wouldn't get noticed, right? And so he was, running experiments and kind of looking at the process of publication in a way that I think should happen in funding, a lot of different things. And then you can kind of learn and adapt and say, okay, this is clearly broken. You may think it's good, but here's data against that.
mhm.
So yeah.
Well, here. I love that. DTFE.
Yeah.
Okay, Josh, thanks so much for your time, and I'm looking forward to following along, and I'm looking forward to using Scite. So thanks again.
Yeah. Thanks so much. This has been fantastic.